get going. Everybody, welcome. This is RocPy. I do a poor imitation of Rich's introduction, but welcome everybody. We are here today to talk about AWS Kinesis. I have a couple of apps, both written in Python. One to push into Kinesis data streams and one to read off of Kinesis data streams. And so I shall, oh, George, you're not letting me share.
There you go.
All right, thank you. Okay. Oops. Need to change that. So this is the consumer. I'm going to bring up this is based on a demo project that is out on GitHub. I just wanted to highlight it. Yes, I believe this is it. No, all right. I will look for this later, but I might even have it here. Yeah, there it is. There we go. So this is based on this repo under AWS Labs, and I don't know if this has the producer in it as well. Yeah, word putter. So the producer app is based on this word putter, and it just takes a list of words and pushes them randomly onto the stream. It is based on Bodo and not Bodo 3. So just be aware of that. It is a little bit, that the syntax in here is a little bit old. It's old style, but it works just fine, even on the newer implementations of whatever iteration they're on with Kinesis. So, and then the client, the consumer app, is based on this sample, which doesn't need Bodo. The way that the consumer works is it actually runs from a Java app which calls this Python as like within the Java process. So it boilerplates a lot of the functionality of dealing with and managing the Kinesis data stream consuming. And so you can focus on more just the logic of processing your stream. Behind the scenes, it's managing state in DynamoDB. And totally transparent to you, but you can go out and see the DynamoDB table and see how it's managing it. This Amazon KCL Pi is where all the magic happens. Okay. So I am on Windows, but I'm leveraging when the WSL and WSL2 in particular. It's a full Linux kernel, so I'm essentially running all of this stuff in Linux. The two apps I actually have in containers, just to further simplify. In one sense simplify, another sense it puts more complication into it. But I set up both in containers to really control the environment. So here I will show you. I was just going to run the producer, but I will show you the producer. So it actually starts here with this is a AWS specific CloudFormation script for creating the stream. All it does is create the stream. I had pulled this from a bigger project that I was working on. So you'll see some things in here. I debug and release versions of things that I'm not going to be leveraging here in this particular demo. But so just so you know, that this is an example of creating the stream with CloudFormation. I frequently use SAM instead of pure CloudFormation. This SAM is a kind of a wrapper for CloudFormation that it's a serverless application model. And so that's how I typically run most of my CloudFormation. It just gives you a little bit more functionality. It's a superset of CloudFormation. So I'm running this template here through SAM, and this SAM toml file has a bunch of configuration, passing it in parameters that are used here in the template. But so this is how I initiated the infrastructure, and then I have this, and this is all in pushing into the stream. So this is the Docker container that I defined for the pushing. I used a Python 3.8 container, did all the updating of it, and triggered the app through this run word putter. Here I'm triggering the word putter. This line up above, I don't know if it would actually work still. I had modified the word putter app to read from a Docker volume, so I could just read from a local file structure and essentially stream that file structure. I use this for testing a stream. So this is how I was running it. I reverted it back to the more basic, just a stream of words for this demo. But I left the lot, like I will put this up in our GitHub account, and I will leave this in here, and I left the logic in there, although I did tweak it to that I had disabled this, the ability to push words when I was reading out of a file. So I re-enabled this. I don't know if I broke the reading from a volume. So feel free to play around with it when I get that up there. So the word putter. And like I said, I did not move. Where to go? Oh, thank you. Code, Visual Studio Code. So I did not write the bulk of this. I just tweaked it. It's the word putter app. Down here is the entry point. It takes arguments. They're defined here. Connects. So one of the reasons why I put this in a Docker container is because this is what uses the Bodo library, yes. And it wasn't obvious how to connect Bodo to a particular, what in AWS connectivity terms it's called a profile. And so it just uses the, in Bodo 3, you can very easily point at different credentials for AWS. And this, I wasn't quite sure how to rearrange this to get it to use the profile. So I set it up in a container and just did the generic configuration of the environment variable to store the credentials for doing this push. So that's, I had forgotten about that. That is why I did the Docker containers. So I didn't have to muck around with my existing AWS credentials setup. So here, down here, put words in stream periodically. Looks like I am not using, okay, so the put words in stream, let's see here. I'm pretty sure. Yep, I'm not leveraging that in here anymore. File. Interesting. Okay. So I thought I had left the file management, but I guess not. Oh yeah, put files in stream right here. So the this logic is still in here as opposed to put words in stream. And I had just, when I was using it, oh, here it is, files in stream. I read right past it. So yeah, if you pass it in a folder, it should read in that folder. Of course. I'm not actually passing in the folder. Nice. Anyways, yeah, so not working. Maybe working. So this will push the words into the stream. I believe it's going to default periodically the way I have it set up. And yeah. All right, so this is putting these words into the stream. If you look up here, what it's doing, well, I guess it's making the connection here. The Kinesis library that is imported up above here from Bodo. Say, tell it which region you're connecting to. This tests the status of the stream to make sure it's okay to actually push into it. It's in a good state. If it's not, it's attempted to be created. And then, assuming that it's then created, things are pushed into it. Yep. Push into stream. And so the only difference here is that this periodically pauses on each call. Otherwise, this just pushes. So you're looping through the list of words, there's connection. This is the connection to Kinesis that was created back when the application started. The name of the stream that you're pushing to. And so if you look here, so this is the word that's getting pushed. And this, let's see here. The record. That partition key. So you have the stream name, the data, and then the partition key. And that partition key is should uniquely represent the word. Up here, when I was pushing the files, you'll see that I am pushing a line of the file and a unique identifier being the file path, where the file is coming from, and the line number that represents this line that I'm pushing. This more realistically represents what it would look like to push into the stream. The partition helps Kinesis with its kind of load balancing across the shards within the Kinesis data stream. So here, for the simple example, it's enough just to push the word value into both of them. So that's pretty much all this is doing. This has been churning along. I'm actually going to stop this and then go over here to all right. So the consumer is a more interesting setup. Because it's actually Java wrapping the Python script, I had to start with a Java container because I couldn't get the Java install to work on the Python container. So I started with a Java container, and but of course, even the Python install, this is what I had to do here to get a reliable Python install. I don't remember why. This is what I landed on for my Python install to actually do the compile. There was a reason why I didn't just do an apt-get, but I can't remember why. So Java, do the updates. These are things that are needed for Python, I believe. And then I ran the Python install. I made sure that pip was up to date. And I was also leveraging pipenv. So I leveraged pipenv in here to turn the requirement, the pip file into a requirements file, which was used by what was that used by? I want to say I don't remember why that was used. There was a reason why I needed to turn the pip file into a requirements.txt, but I don't remember why. So the definition of the Docker file, so the app itself is in this Kinesis Consumer folder here with run consumer Docker. To run it not in Docker, I have this. There was, I believe, a slightly different path. Oh, that's right. In Docker, so yes, in Docker, it just had these already set within the Docker container. For when I was running outside of Docker, I created these environment variables that I pulled in and set for this context. So this is the Python script that runs from this code from Python. You can see here, what's happening here is we're actually running this helper script that they provide as part of the Docker container, as part of the GitHub repo, this KCL helper. And all this KCL helper does is produce the Java call that starts the application. So it builds the class path and it points to, it points to this file, which references your, the application, this process log stream. And the stream name that we're pushing into, and a bunch of other settings. It's pretty well documented right in here. Interesting that this processing language is really just informational. It doesn't, this could say, hey, George. It doesn't matter. And yeah, you can specify the region that you're in, how you're passing the credentials, and a lot of other things that you can tweak, like max records, the maximum records to fetch from Kinesis in a single get records call. So this is all of the things that are done within the Java app, and the records are retrieved and then pushed into and passed into the Python script. So in here, the bulk of it is this record processor. It's based on processor coming from the KCL, and it uses this base processor. And what this does is, that's the bridge to Java, is that record processor. So it will trigger these events checkpoint, process record. This process record is really where you put your logic. As it gets to the different records that are coming through, you land here. And this is like this is where you do your business logic. So a lot of this is still boilerplate in here, but it allows you to leverage things like how this process records is batches of records that get passed into the script. And so then this, let's see here, you have your checkpoint call up there, process record. So this is where that process record method is actually called. So process records receives, let's see if I make sure here. Yeah, so this is truly the entry point from Java. The Java wrapper calls into here, passing in the records to process as an object with the property records and loops through those records. And so you perform the processing of data in here on the process record. And you can do so, and then here it all depends on what kind of stream data you're processing. Like in the project that I was working on, we had pretty well-defined log files, and they had sections, and it had a start and an end. Well, so you had to detect the change, and so what we were doing is we were just looking for the end of each section, because you could potentially start in the middle of a section. And so you know that you've reached the end of a section, but by the time you reach when you detect the end. And so you can do transitions there. Here, I'm just passing a stream of data. There's no beginning or ending. So I'm really just printing out what I've received. I tried to throw in some here some different little bits of logic to kind of represent some of the things that you can do. I have this stream config where up here I defined a JSON file where with one property in it that is a list of strings that are things that I want to skip. So I use this here, exclusions, if the decoded data from the stream, if this exclusion, oh, you know what? This was old data. This should be a starts with. So if this starts with the exclusion, then skip it and just return out of this. Previously, the logic that I stole this from was looking for full strings. If that full string was found, then skip it. So, well, I'll leave that for now. So any word with an A will be skipped. We'll see how that works. Here I'm doing some aggregation logic. It's just a custom class. When I initialize the class, I create two properties. First item received, which will be a date time, and a mapping of groups. So the key, I take the first two characters of whatever is passed in and use it as the key. So I'm grouping by the first two characters, and then I create a list of items that have those same first two characters. Here I'm pulling in a date time. This is actually the correct, quote unquote, correct way of getting a date time with a UTC with actually maintaining the UTC information. If you do UTC now, something that I was actually just doing this project made aware of, it doesn't actually save the fact that it's a UTC date. It just happens to be a date time with the UTC time, but the time zone information is not maintained, so it kind of makes it less than useful. If you do this though, you get both the UTC time and it saves into the date time result the fact that this time zone is UTC. So you know that as you're modifying it, the time zone that you're working with is this defined time zone. It's very important when you're dealing with cross time zone information that you know what time zone you're talking about. But that's a side note. And so then back in the stream, back here, I get the current time and I compare it to the first item received. If it's been more than 30 seconds, I just, right at the moment, I'm just printing it out and creating a new aggregate instance. So here I will. In this case, run. And with any luck, we'll pull down some stream data. The stream data that I had pushed, yep, there we go. Let's see here. Skipping unexpected. We should see. You know what? I'm not sure if we're actually capturing the log here. Okay, so I am going to do this. I know this is output. I'm just going to do Okay, so because it was sleeping, that means it reached the end of the stream. So I'm going to push some more. So here, let's see if we can see some more now. Oh, there we go. Here is the aggregate output. Things just move too fast over here. You have to get a nice big output to say, oh yeah, there's your result. This is quite verbose. And as you can see, none of the words have the letter A in them. So here. So we have DU for ducks, lots of ducks. WO, wonderful and wobble. So yeah, I took those words, filtered them, and grouped them. So wow, that actually worked. So yeah, one thing you'll notice in here, the data comes through in encoded. So you have to decode the data saying that UTF-8. One of the interesting parts about the Java app is that it will, like, if this fails, it will, and even the Kinesis in general, it will replay, but it will, the Java app will also buffer and retry things that fail. So if you have a problem, if you have your app actually throwing an error, you can pause the app, pause the processing of the stream, fix your problem, push the fix, and then restart the stream, and it should at least retry the first failed record and continue processing the stream. So that's pretty nice. It works pretty slick. Streams, Kinesis streams in general can also be replayed, so you can reset the pointers to kind of like a stream when you're doing a coding, when you're reading a file. If you've worked with streams, you know that once you reach the end of that stream, if you want to reread the stream, you have to point it back at the beginning of the stream. You have to physically say, point, the stream index needs to be back at 1 to read through the stream again. Well, the Kinesis data streams work the same way. Though being a stream, and unlike a file, this stream is indeterminate. There's no real beginning or end to a Kinesis data stream. So it's whatever it has in memory, or it can be it's a configured length of time. I believe it can be up to a week. I could be wrong there though. But it's a configured length of time that you can have information that it can be replayed from your data stream. Is there anything that anybody wants to see a little bit more, a little bit closer?
I just had a quick question about Kinesis. Is it So from the terms you're using, is it the same or similar to Apache Kafka?
It is a similar implementation. Kafka is just a different streaming framework.
Gotcha. Okay, so it still has stuff like topics and partitions and stuff like that. Okay. Is it the same terms or do they have like some?
I don't know. I think so. I am not I'm not as intimately familiar with the terms, especially how Kafka uses them. And I've only used this on one project, so I don't know for sure how everything lines up there terms wise.
Gotcha. Okay.
I did have some fun trying to debug this. I did have this PVSD working, which enables breakpoints, and within Visual Studio, let me see if it works. So I had, let's do it here. So that's still going. All right. I think that's right. Yay. All right. With this going, I just need to wait to see. All right, well, I didn't see it, but it seems to be in the loop. We shall try debug. Does not seem, it looks like it thinks it's running. Now, why are you sleeping? Oh, because this stopped. Hey, look at that, it worked. So with that PVD, this was a little bit tricky to make work for whatever reason. I think I was overcomplicating it really. But once that library is loaded, I will include the debugger setup, but you can debug, set breakpoints, and step into this processing. You see the data. So yes, it comes through as binary. And so you need to turn it into UTF so you can actually get the string and do stuff with it. And as you can see down here, the Java app is really what's producing this output. So you can, I'll just let this go now. I will just let this go now. So, So this, I will show you, is it here? Settings. Yeah. So this is the configuration that connects to that, that's the library, PTVSD. So this is Visual Studio Code specific, I believe, but you tell it to, let's see, Python attach, I believe is the remote attach. This is the default port number for that library, and we're connecting to the local. Oh, that's right. This connects actually through the Docker container. So in the Docker file, I expose that port number. So that is how this works through the Docker container. Even though I'm running it in the Docker container, I'm able to set the breakpoint in here and still debug even though it's running within the Docker container. So that was kind of fun. And there's just so many different things that you can do with this. You can put, like, some of the things that we did with it was we used the log data to create metrics and push metrics into Amazon CloudWatch. We also pushed the log data into an Elasticsearch cluster. And so there's lots of different ways that this can be leveraged for analyzing real time and being able to create custom analytics when the stuff that's out of the box doesn't quite fit what you need. Any other questions? Comments, concerns?
No, that was great.
Cool, awesome. Yeah, this was a lot of fun, this little project. And the Docker actually came in super helpful, being able to encapsulate these older, that particularly the word pusher, encapsulating that was helpful. And just, I found it to be like the ultimate virtual environment. Cool. Well, that's all I got.